A very bright good afternoon to everyone. It's my pleasure to introduce Dr. Atul B. Andare, a distinguished professor in the Department of Mechanical Engineering at Visvesvaraya National Institute of Technology, VNIT, Nagpur, India. Dr. Andare's academic journey includes a PhD in Engineering from Indian Institute of Technology, Bombay, and MTech in Engineering from Visvesvaraya National Institute of Technology, and BE in Mechanical Engineering from Shivaji Institute. And before his tenure as a professor at VNIT Nagpur, Dr. Andare held position as an assistant professor at Sardar Vallabhbhai National Institute of Technology and the IIT Bombay, showcasing a breadth of experience across prominent Indian academic institutions. His research expert spans a wide range of critical areas within mechanical engineering, including machine and CNC machining, design engineering and mechanical designing engineering, production engineering, product design and development, as well as product development, design optimization and engineering optimization, finite element analysis. Now I request Dr. M. Lokande sir to provide sapling and a book for our honorable guest speaker of Dr. Atul B. Andare. Now I request Dr. Atul B. Andare to have the stage.
शेयर करना पड़ेगा स्क्रीन. अच्छा, सबको नहीं चाहिए होगा तो बंद कर दो. मेरे को चाहिए सिर्फ. Good afternoon to all of you. It is my pleasure to be here. I may not be a perfect speaker for the theme of the program, which is related to AI and smart grid kind of things. Whatever I am going to present is basically work done by my PhD scholar, Dr. Chaitanya Bhore. And if you talk of AI, Dr. Kane is here, who has used AI earlier for diagnosis of faults in gearboxes. Chaitanya has worked basically on the solar PV modules and their vibration analysis. So if you talk of the background, I think something around 2017, Nagpur Metro work started, and there a number of solar PV modules were installed adjacent to railway tracks and on the shades of the platform or on the adjacent building and all that. And so during discussion sometime with the metro officials and amongst us also, we felt that what will the effect of the metro vibrations and kind of impacts they get on the solar PV modules and their performance. Will it be affecting them and all that? So from that point of view, later on Chaitanya joined as a PhD scholar and we took up this problem. आगे बढ़ेगा? So first I will talk of what is the motivation, as I said briefly about the Nagpur Metro. Then whatever presentation is here basically is the presentation made by Chaitanya related to his PhD defense, we can say. Then overview of the topic, what we found from the literature and actual work, whatever was carried out. So as we have seen, 11.2 megawatt nearly of the capacity of solar PV are installed on the elevated stations and ground level stations on Nagpur Metro. a large number of panels are there, and all these PV modules are naturally they are subjected to wind excitations and all those because of the atmospheric changes, and main coming is now additional input that is coming is vibration from the metro tracks or metros, and maybe because of the structural resonance also. Now whatever found out from the literature, that all these vibrations or the excitations because of wind and all that can cause micro cracks, delamination problems and degradation of the solar PV panels, and ultimately output is reduced. So we searched extensive literature, found that there are very limited studies on the specific vibration related problems on the solar PV models or impact of that. So we decided our objective that we'll look at the vibration analysis of the solar PV models and how we can mount them effectively so that there is less damage or less degradation to the panels. And the mounting can be different, so we selected number of options for mounting and like that, though the Nagpur Metro may have mounted panels in one particular fashion. So basically what we aimed is to find some or to decide some guideline or to evaluate some procedure for mounting of these panels to reduce its performance or to reduce its degradation basically. So this is what we have seen already. I have told you that dynamic behavior or dynamic excitation effect on the solar PV modules are hardly studied in the literature. So we took up this problem, and this was also the requirement to some extent, though it is not officially done for metro. This was also the requirement of metro. We have done some work on metro for the vibration and noise analysis of the metros, but that was not part of this work. It was independent study also, but we have measured vibrations at different locations and all those things. So as I said, these modules which are installed, solar PV modules which are installed, subjected to dynamic loading. Whatever guidelines are there for the solar PV modules, that is basically dealing with static kind of conditions. Dynamic conditions are not taken into account in the guidelines. So generation and propagation of cracks and micro cracks are most important or most significant effect that are observed. And obviously they propagate. Once this cracking starts, it propagates and the panel is damaged over a period of time. If you look at the Western authors' literature, they will more talk of rain, snow and those kinds of effect on the modules. So what we decided as the aim to design effective configuration for mounting. So mounting can be in different way. So how to mount the panels, that was the objective that we decided. So the panels, obviously we are talking of subjected to metro or wind induced vibration because we are discussing panels adjacent to metro tracks or the on the platforms. So objective we decided to find out or determine quality and quantity of vibrations. So how much vibrations are there, what type of vibrations are there, what are the frequencies, what are the amplitudes of those vibrations, that we wanted to check. So we had actually measured those things. So how the panels, PV modules will respond to the modal or harmonic vibration response, how it will be there, what will happen, what is natural frequency of the PV modules, if we give some excitation to the base because they are mounted on some base, how that if that base is excited because of some vibration coming from the metro or those kinds of excitation, what will happen to that, that we wanted to find out. Then first we took up vibration excitation problem. So in vibration, force vibration, normally we have different types of vibration problems. We say force acting on the body, some body is there, some we have a spring mass system, we assume that some force is acting on the mass, bearing force is there, dynamic force is there, how the system will respond. Another class of problem we talk of spring mass system, the vibration is from the base. So the problem which we are talking of is that kind, that vibration is coming from the base. So what will happen to the system, how the system will respond. That is the kind of problem that we discussed. So then we shifted our attention to, apart from vibration, what will happen because of the wind. So the panels are mounted maybe one behind the other, and because of that, if some wind is coming, how the wind velocities will change, how the pressure will change, will it be having some effect on the PV module and its vibration. And ultimately we came to check, or we designed or tested some materials for damping. So if you are requiring to mount, then what kind of damper can be better for the vibration. We defined our scope as mentioned here. So basically we targeted the mounting configuration. We did experimental or actual vibration measurement on metro track, on the railway stations which are at the ground level, as well as elevated stations, on the platforms and various locations. Then for the wind induced vibration, because we did not have the facilities like wind tunnel and those kinds of things for testing under actual wind condition, we just limited ourselves to the simulation related problem or simulation analysis. And as I said, we tested the dampers and to find out the effectiveness of the damping materials. So if you look at the literature, we had extensive literature survey, and what we found that the crystalline silicon technology is widely or most popularly used, and cracks and micro cracks which are developed are the major cause of concern, or they cause the degradation in the performance. So as I have already discussed, this increase in vibration can cause the damage. One of the important findings which we also observed ourselves, that the natural frequencies of the PV modules and the excitation frequencies coming from the metro or those kinds of excitation, they are in the similar range of frequency, means say 0 to 150 or maybe 0 to 250 hertz. So it is possible that sometime you get excitation which can excite the natural frequency of the PV module, which can cause a greater damage. And as I said that the studies on this kind of analysis were less, so we focused on this problem. So these are some of the photographs. This photograph is actually for the Kochi metro. You can see on the rooftop PV modules are there of the metro stations, and what you see here is the Nagpur metro picture. So adjacent to the track you can see number of PV modules mounted, also on the rooftops of the platforms they are mounted. So all these are very close to the tracks, and as per the guidelines, the railway guidelines, these vibrations and the noise coming from these metros, there should be some limit. So we have tested some of the locations for this also. So this is showing some, this is taken from some literature, some sources. So how the micro cracks can progress, how it can cause damage when there is, say, on the top you can see on the left side there is no bending cycle or loading is not varying, then some bending cycle say 300 and 3600, how the cracks develop and potentially electrically insulated area develop. And at the bottom you can see the infrared pictures also, how the cracks are developed in the modules because of the vibrations, or you can say number of bending cycles which have increased. So as the system is subjected to vibration, this is going to cause damage to the PV module, that is clear. So first objective that we have decided, that we wanted to know the quality and quantity of vibration which is coming from the metro. So we did some measurement as shown in the figure. Actually on track we did the measurement. This was during the testing period of the metro. I think sometime around 2018-19 we went to Khapri metro station, which is the terminal station we can say, and there they you can say operated the train for the testing purposes, and we tested on the track actually what kind of vibrations are coming. So train speed was limited at that time because it was not fully functional. It was around 10 kilometers per hour, I think. So we mounted sensors on the track vibration accelerometers and gathered the data from that. As you can see in the picture, on the platforms, on the adjacent buildings also we measured vibration levels. Now while measuring vibration on the track, so sensor is located at certain point, say train is coming, going over that sensor location and going further away. So whatever signal we acquired, we divided that signal, you can say, in three parts. Train is approaching, train is crossing the location where the sensor is put, and then it has crossed and going away. So we divided those regions and got some vibration information, converted that into the spectrum. FFT was obtained, and we could see some particular frequencies dominating at larger amplitude coming at those frequencies. So these are the plots, acceleration versus the frequency plot spectrum, acceleration spectrum we can see. Then on the stations also, on the platforms also we measured vibration. Again on the top you see the elevated metro station vibration measurement. At the bottom these are the ground stations vibration measurement. On the left red spectrum is the acceleration spectrum, then converted that into velocity levels, because as per the RDSO guidelines they require the parameters to be in terms of velocity. So we converted that into velocity, and then at different stations we measured. So 4 or 5 stations, whatever we measured, we compared the results, what levels we are getting and all that. And that is you can see the rightmost or the right hand side plot, that is measured in terms of octaves, 1/3 octave. So instead of having a conventional frequency scale, that was divided into octaves and that is plotted. Again same thing was repeated for the adjacent buildings. So selected some adjacent building and did measurement on that. Now you can see comparison of metro vibration on tracks, metro station, adjacent building in velocity decibels versus 1/3 octave frequency. That is plotted in the bottom you can see. So obviously it is more on the track and it will be lesser on the adjacent building. But again, as I said, there are certain guidelines. So the railway guidelines say that at certain distance, if some building is there, how much vibration is permissible and all that. So we have to check whether it is in the limit or not. So from this measurement, what we observed that obviously track vibration will be high, and the entire frequency band, you can say audible frequency band, 10 to 20 kilohertz, that is are there. For velocity, you see major amplitudes up to around 1000 hertz, and observable range was reduced to 10 to 5 kilohertz for acceleration and 10 to 250 hertz for velocities. So higher frequency amplitudes they were not seen if you go away from the tracks. And at the ground level, that is at grade and elevated metro station, if you compare, elevated metro station showed higher amplitude of vibration as compared to ground level metro station, and they were in limit. We have checked that. So as per the Federal Transit Administration guideline, FTA guideline, these vibrations were in limit, and the frequencies which were there, induced vibration 10 to 250 hertz, and the natural frequencies of the PV modules lie in the range of 20 to around 150 hertz. So they are overlapping. So it is possible that some of the frequencies which are coming because of the excitation, that can excite the natural frequency of the PV modules. That was clear. So we actually verified that. Then coming to actually PV module. So we try to determine the natural frequency of the PV module experimentally as well as through the FE modeling. So we model also, we checked. So this is showing the actual photograph of measurement setup. There are 3 locations marked, 1, 2 and 3. Location 1 is showing accelerometer mounting position. Accelerometer is shown at in the second figure, figure B at the bottom. We mounted the accelerometer. Location 2 is for corner element, means as you can see the 4 corners of this corners are supported by some material. So in the FE model we had fixed some points. So these corner points were fixed. So those are, you can say, represented here. And then we use the OROS system to measure that. And various mounting configurations we tested, or we checked first in simulation, and some of them were experimentally verified. Now here 10 mounting configurations are shown. You can see from top, say first mounting configuration, all corner elements fixed. So it is labeled shortly ACEF, all corner elements fixed. Then you can say one edge is fixed, then other side 2 elements are fixed, then 2 edges are fixed, shorter edges are fixed, then one short edge, one longer edge is fixed, and like that. So different arrangements are considered, and like that we explored, we can say, 10 different mounting configurations for this. And the measurement which was done, out of these I think we have selected 4 configurations for actual verification by measurement. Now for simulation, the model which was made, you can see the PV module that is having a layer of glass, followed by EVA, followed by again EVA layer, 0.4 mm, 2 layers, and then TEDLA. So this model was constructed, the properties or the technology that is used, you can see is crystalline silicon. That kind of PV module was modeled, and what is the rating of the module, etc., that is shown here. So now for all these 10 configurations which were there, we found out the modes of vibration for these models in 10 different ways, how they are mounted and how they will respond in each mounting configuration. So you can see one of them here. The modal analysis was done, and you can see first mode to 6th mode for the particular mounting configuration. That is mounting configuration 1, and the table that is here, that is showing comparison of 4 mounting configuration that we have tested actually, and the natural frequencies or the modes you are seeing 1, 2, 3, 4, 5 or 6, wherever it is there. So finite element result, what is obtained, what is experimental result that is obtained, or what is the error that has come, and percentage error that is shown. So more or less you can see the error is most of the times, in exceptional cases it is somewhat, maximum is 14.85, otherwise it is within acceptable range, maybe 5% and like that, or 10% up to maximum. So what we can say is our finite element model was good enough to represent the actual conditions, because actually we also got the similar results in case of 4 configuration that we studied. Then the next, so this helped us to determine natural frequencies of the various mounting configurations when the model is there. We have data of excitations, right, and we have data of now natural frequencies of the panels when they are mounted in particular fashion. So now if I give excitation to this module, to the base of the module, what will happen? That has to be tested. So now we are knowing what are the input frequencies, input amplitude that can be there. So range of amplitude, range of frequencies are known. So this actually involves harmonic and random analysis result. Means you give some harmonic excitation to the base, and also you give some random excitation to the base, covering all the frequencies which are there, covering some wide range of amplitudes which are there, so that we know how the panel will behave, how it will respond, what kind of amplitude we will get, at what frequency it will be excited more, and like that. So some of the results are shown here. 2D and 3D plots are shown. Now all the 10 configurations are shown. You can see every graph is showing 1 to 10, and the last two graphs are showing particular dominating peaks. Then actually we submitted a paper on whatever work we had done, and we received some comments from the reviewers, and they asked us to not only study one technology or one kind of PV module, you also explore the other module. So we explored the other two methods, that is thin film technique and the ultra thin double glazing type of solar PV module. Also explored this whatever method we have used, same method we applied for all these also, all the other two techniques, and totally 3 we evaluated. And then out of the 10 mounting configuration, finding the random vibration response and the harmonic response, we decided what can be the best mounting configuration for the particular kind of PV module and what is the worst mounting configuration. So you can see here in the table that 3 techniques are mentioned, or 3 technologies are given, and best mounting configuration and worst mounting configuration that are decided or that are determined. So with the help of this, now we know if you have particular type of PV module, if you mount it in a particular way, whether it will give you reduction in vibration or it will result into damage to the PV module. That can be decided, you can say, or that can be found out beforehand, before you actually mount it. So this will actually help us to decide particular mounting configuration for any PV module that you have. So the next part that we did was trying to explore the wind excitation, wind induced vibrations on PV module. So again, as I said, this was restricted to 3D simulation only, not actually verification was done, but while simulating we had tried to see that our model is correct and we get the appropriate result. So the 3D CFD model validation was done first, cube was considered and flow through the cube was considered, and all these details of simulation are given, number of elements, what air velocity, density, etc. considered, and based on that coefficient of drag was calculated through simulation, and that coefficient of drag which we obtained was 1.004, other digits are there, 5, 5 and so on, and as per the references that are shown here, the coefficient of drag for a cube is 1.05. So we almost got the correct value for the coefficient of drag, and so we established that our model is correct for the simulation, and then we went ahead. So you can see here now 4 figures are there. Actual computational model, you can see 4 panels, 4 rows of panels, one behind the other, they are shown. Then the top side, right side figure shows you the pressure distribution, how the pressure is varying. The bottom left shows you the velocity and streamline variation contours. So figure is small, it can be expanded and you can see the detailed picture of that. Basic point is, when wind is coming from one side, you have a panel like this and number of panels behind that. So this wind that is coming, velocity is coming, it is having some pressure. So there is going to be some pressure variation on the panel which is behind, and similarly velocity distribution will be different. So that pressure variation along the face of the panel will be a source of excitation for vibration, because that pressure is varying. We have assumed first constant wind speed. Even if the wind speed is constant, you get variable pressure on the panel surface, and that will be a source of excitation. That is the first part that we did. Then how the air will flow over 4 panels which are one behind other, that is shown in tandem arrangement. So velocity variation, pressure variation and velocity streamlines are shown. And then this is plotted in terms of the fluctuation, pressure fluctuation signal, how it will be varying with time. So pressure is varying and FFT of that certain frequency will be dominant. It will be having certain frequency at which the pressure is varying. So major, as I said, is so some results are shown here. 3D CFD analysis. So you can see the first figure. A is computational domain, then pressure contour in XY plane, pressure contour in XZ plane, velocity contour in different planes, and XY is combined. So last figure is the velocity contour in XY, XZ plane combined. So in different directions, how the velocity is varying or pressure is varying, that is determined. So if you have number of panels side by side and then one behind the other, how the pressure is going to change on all the panels or how the velocity is going to be different, that is, or that you can find out, and that effect can be determined. And again, as I said, with constant input velocity. Normally natural air velocity will be changing. The velocity streamlines are shown, so this can be explored to get an idea of the exact distribution of the pressure and velocity. So now this is showing actually how the pressure from the top to bottom of a panel, how the pressure is varying. And you can see continuous variation, red portion is the maximum value of pressure and then gradually blue is lower. So PV model, that is PV01, second PV model, means one after the other there are 4 models, so 4 PV panels. So how this is going to vary, that is shown here. So first PV model, second PV model and so on. Now the next part is assuming some varying speed. Wind speed is varying, fluctuating wind speed. Maybe that can be taken as random, but we have taken some sinusoidal kind of variation. You can see sin 2 pi, 10 pi t and some cos 20 pi t kind of. So this is related to, I think, wind that we get in Nagpur region, right? So whatever wind fluctuations we get in Nagpur region, minimum maximum values, we try to take that into this equation so that we can have variation of wind velocity and what will happen because of that on the pressure and velocity distribution. Important aspect is just off the track. Most of these measurements were performed during COVID times, and it was actually very difficult to get access to all those locations or the permissions and all that. So it consumed a lot of time for that. Because of COVID also, almost for 6 months nothing was allowed. So what we found out is that variation of pressure and velocity on the PV model, that is there, and because of the earlier PV model you get some vortex formed before the second PV model, and that is going to cause some excitation. 3D CFD obviously it gives more detailed picture of that variation. In fluctuating inlet wind speed, it was found that pressure variation frequencies on the PV model surface were the same as that of the input wind speed fluctuation. All 4 PV models showed similar fluctuation results. So wind flow over the PV model generates fluctuating pressure on the PV model surface, effectively generating dynamic loading. So we just established that wind will cause dynamic excitation to the PV model, and then obviously you can explore again what will happen because of the variation of wind and all that. Then, as I said, one of the objective was to check actually the damping materials, how which damping material can be better for particular mounting configuration. So we designed some exciter, a vibration exciter was designed, fabricated. We simulated it also in the ANSYS software and tried to find out how it will behave. We first determined its natural frequency and all that, and so that if we want to use it, then we wanted to avoid those natural frequencies so that we can get proper measurement. This is showing the actual testing. So you can see a panel mounted on a structure. This vibration excitation was done by providing a rotating disc with some unbalance. So that frequency motor speed can be varied, so you can get different frequencies, and if you change the unbalance, you will get the different amplitudes. So by using that, we tested the panels for different excitations. 4 different materials are shown here along with the table. So neoprene, footwear rubber, silicone and synthetic rubbers were used. And for particular excitation, what kind of response we get from the PV model. You can see accelerometer also below the PV model. So if you are giving some excitation, what is transferred or what is actually received at the PV model, that is checked. So this was physically tested, and you can see now the actual response is found out without damper and with the 4 different damping materials which were used, and how much reduction was there with particular damping material, that was also checked, and from that maybe we can decide what can be the best material for providing in certain situation. Now when we check these materials, then we got some suggestion that you try to check other materials also which are also possible for damping, like the sorbothane rubber, nitrile rubber and synthetic rubber, etc. So that also we tested in simulation, right? We did not get the actual material, we just tested on simulation, and we obtained the response of the system and tried to find out which one can be better. So if we compare all the materials which are tested, you can see graphs here, damper material and versus the amplitude that you are getting for a particular excitation. So you can obviously for no damper amplitude is higher, and then as we apply various materials, so we know which material will be best and all that. So second graph is talking of percentage reduction. That's why percentage reduction is you can see EPDM is showing 38 and neoprene is showing 48% reduction. So we know which material is good for damping. So as I said, now conclusion based on this 4th objective that we have used. Natural frequency obtained for the shaker table, then actual we tested the panels on that and also simulated the damping materials performance in the simulation, and we got neoprene as one of the best material for damping purposes. So if you look at the overall work, what we can say, this metro vibration can excite frequencies which are close to natural frequency of the PV models which are used for solar energy generation. And if some frequency, natural frequency get excited, obviously you can have a damage in the panel. So that panel can get, though the life is expected to be around 25 years, it can damage very early. That is the main point. So we decided the best and worst position for the mounting configuration. We analyzed the flow patterns over the various configuration, pressure distribution or pressure variation and velocity variation, and experimental and actual verification of the simulation based damping materials we tested. So this was all about whatever I wanted to share. All credit goes to Chaitanya for whatever is done or whatever I have shown here. Based on that, we had some publications, 2 in solar energy and other in conference proceedings or kind of book chapters, we can say. This is all from my side. If you have any queries, any doubt, please feel free to ask. Now, इससे maybe based on the distance that you are having, adjacent to track है. Now, on the top means that structure is there. So platform, then columns, and then so amplitude which is going maybe at the top can be slightly lesser. This adjacent which is there, which is very close by, so they may be getting more amplitude of vibration. नहीं, I am talking of distance from the source of excitation. Transmission path लंबा हो गया, so that vibration will be reduced maybe. That will be subjected to slightly lesser vibration. Samruddhi we have not done so far. We have definitely done some work for Mumbai Metro. Yes. No, but we are not involved at this stage right now. Yes, that is possible to do, but presently we are not involved in that. No.
Are there any guidelines from Metro?
We have done this noise and vibration analysis for New Mumbai Metro, all 15 stations. We have also got some requests from Nagpur Metro. That's still in progress. Output will be reduced. Output will be reduced.
Where to place sensor? Are there any guidelines for placing sensor?
For measurement of vibration.
On track. The outcome is shared with the Metro.
Outcome, now this is actually not sponsored or supported by Metro as such, but idea was taken from Metro. They are just interested in knowing whether the vibrations are within limit or not. Measurement on track was actually means quite challenging, you can say. His father is an expert in solar PV. Means
Morning you met him. Police player.
Right? Now the question is how much damage, how much cracks, and what is the loss. That has to be established. That is good.
He's the senior most participant. Activated VI.
Natural frequency, normally we do what is called as impact testing. So if this table is there or podium is there, I put a sensor. I just excite this, give some impact, impulse response, what you say in electrical engineering, impulse response of the system. So you give some excitation, allow it to vibrate on its own. That is natural frequency. So now it can have number of natural frequencies. Normally all systems will have number of natural frequencies. So first natural frequency we say first mode, second mode. It vibrates in different shapes in particular frequency. You will get large amplitude when you check the spectrum. At a frequency you will get a large amplitude. If you are giving impact, it is vibrating, maybe for some small time. And as you are not applying force continuously, it is vibrating on its own after giving the impulse. That is called as free vibration in our terminology.
What was the period of your experimentation? Your period of experimentation. What was the duration? When the certain frequency is applied, what is the duration for which you apply?
That is just an impulse, sir. Normally we get what is called as modal hammer, which has a force sensor. So you give impulse, and that is input. You measure acceleration, that is output. You can find out the transfer function actually. And you can find out the phase also. Means if you are having in force input and output also the acceleration, you can find out the phase also.
PV technology change.
EV technology, I have shown three different technologies we have tested. Obviously, each panel, if construction of the panel is different, it will respond differently. It will have different natural frequencies, even in mounted condition. So, particular panel will have certain behavior that we have to check. Means maybe what is in our hand, if some say PV panels are to be installed, we can suggest how it can be mounted. If you are knowing suppose it is going to be mounted near the metro track, so mount it this way so that it will have less vibrations, so its life will be more. That also can be checked, means aircraft related, that also can be a study. Mono. That is possible.
Right. So very good work done by Dr. Vivek. Can be hand moment.
Thank you all.
Thank you so much, sir, for your expert lecture on effect of dynamic loading on PV module.
So we'll be having next lecture by Professor Ballar sir. So he will be giving the lecture on condition monitoring of solar PV system, especially the panel.
कहाँ रखा है? ये सब कागज लेके आओ, फाइल में लगा दो। श्रीनिवास के पास फाइल। इन्हें इधर से फाइल। We want next sheet by Balla sir. We will read. We will read. बिजनेस की बात करके बिजनेस की बात
क्या मुझे पढ़ना है ना होता सर सर आले हाँ slide. Hello, hello, hello. There is no. On कर दो.
कुठे आहे ते सांगू दे मला चेस्ट बिना है का वो अच्छा ऑनलाइन के लिए कैम में जाना पड़ेगा कैम में यही पे जाएंगे ये और ये दो है तो ये पीडीएफ हो गया है ना इसको ओपन करेंगे ठीक नमस्कार
10 years field
Good afternoon, one and all. It's my pleasure to introduce Dr. M.S. Ballal sir, a distinguished member of the Electrical Engineering Department at VNIT Nagpur. Dr. Ballal possesses a strong academic background, culminating in his PhD awarded in 2007 by RT Menu Nagpur University, where he specialized in the condition monitoring of electrical machines. Prior to his doctoral study, he earned his MTech IPS in 1997 from VNIT, formerly VRC Nagpur, focusing on induction motor fault detection using ANN and fuzzy systems. His foundation education includes BE in Electrical Engineering, obtained in 1993 from Government Engineering College, Aurangabad, and a Diploma in Electrical Engineering from Government Polytechnic, Yavatmal in 1990. With a rich professional history spanning of 15 years in the power sector, Dr. Ballal brings valuable practical experience in his academic pursuit. His research interests are diverse and impactful, encompassing critical areas such as condition monitoring of electrical components, DC microgrid, control and protection, power system, power quality, and power theft. His expertise in these fields contributes significantly to advancement in electrical engineering and power management. Now I kindly request Dr. P.S. Kulkarni sir to felicitate Dr. M.S. Ballal sir with a sapling. Now I request Dr. M.S. Ballal sir to give his speech on condition monitoring of solar power plant on Spark technology to enlighten with his speech. Thank you, sir.
कॉर्डलेस आएगा दे देना फिर कॉर्डलेस अच्छा ठीक है इसको यहाँ रख देते ये लगा देते हैं इसको इधर रखता चले करें स्टार्ट सो गुड आफ्टरनून ऑल ऑफ यू सबका खाना हो गया है लंच हो गया है चाय भी हो गई है और हमारा सौभाग्य है कि हमारे गुरुदेव यहाँ पे है फुटा सर आज यहाँ पे है सारी बड़ी बड़ी हस्तियाँ यहाँ पे और मुझे मौका मिला है आई गॉट दिस अपॉर्चुनिटी टू प्रेजेंट स्मॉल अमाउंट ऑफ वर्क actually I am not related with because these persons are working in the solar domain but this come because of the industrial project only so I think that इसको यूज करना है क्या okay so okay so GAN program is very important program for all of us and in this one I am presenting this condition monitoring of solar power plants using spark technology. So spark means what is the meaning of spark? Let us see what is the meaning of spark and my PhD scholar Gajanan Adkine, he is working on this topic because we have started our one year back and he still continue because we are not getting good publication. We have patented some conference publication but now we are striving for getting some journal publication. So spark means this is a solar panel S&P assessment reporting kit. So this is a kit which is fabricated and if it is possible, if the environment permit us, we will try to give you the demo also. The demo is also arranged about this kit. So in this one, this project is funded by the Arise Engineers Private Limited, Vadodara, Gujarat. So it is also from Gujarat. So they have all the time supported us and 2-3 projects they have allotted me and so this is also a very interesting project and they say that you design some kit, some system so that it is possible for us to check the condition of the solar panel in a lively and real time also. So these are the contents, motivation and what is the need of condition monitoring. One by one I will discuss with you. So the strong motivation nowadays, if you can see, that the government has decided to go for the removal of the solar carbon footprint and then there is advantages already discussed so I don't want to repeat them again and again but one important motivation here is that industry gave me the project. That's only the major motivation. That's why only we have started this project. Otherwise, I don't have any information about these things. Okay, I was not in a touch with the this what is solar, how it works, and nothing. So, okay.
You can use the point.
Now it is possible with this. Okay. Here. Okay. So this is the major important thing that industry sponsored project. And so many advantages are still there and industry's demands are different. They have given me the chance. Another thing that these are the theoretical things that I just collected for making the presentation that this 36% or more than that the renewable energy is now going to get increased, and it is decided by the society as well as by the government. So these things are there, and definitely we now most of the things are going to get converted, because the problem which is related with this environment, everybody is suffering because of it. And interesting thing is that is the PM Surya Ghar Muft Bijli Yojana is also interesting thing, and it is now mandatory for many apartments to install the solar panels and use for this. So many things are there going to get changed. Now the net meters are also there. We are fixing the net meters. Every home we are connecting with this net meters and like that. So things are like this, and they are changing. So I think yes. Now come to the point. We are discussing about the PV panel only. There is solar thermal also. So there are various types of faults taking place in the PV panel. There are many number of faults. Important 6 types of faults are listed here. So there are in different literature different types of faults, and things are given. So physical damage, electrical damage, shading, then hotspot, dust and debris, open circuit, and with the anti-error diode, and so many things are given. In short, this is I have collected the probability of the faults in the PV panel, because our concentration is only on the PV panel. Or whatever the problem is, because that is source, that the generator is only we are considering. We are not going toward the inverter side or other sides. Our focus is only on the panel. So what is the panel condition, and how this panel is suffering because of so many other n number of contingencies condition taking place in the due to environmental or other types of problems. So this is in short the probability, and here if you can see the dust and debris that we have considered, then shadow condition we have considered in our work, anti-parallel diode and cables, this we also consider. In some way we try to consider the degradation as well as the defective cell condition and small amount of physical damage. So most of the things we have tried to cover in our this hardware project. Now, why to go for the condition monitoring for the solar PV panel? So these are the reasons behind it. So once we know the condition of the system, then we can go for the proper type of treatment, just similar to our body. If we know about the things of, say, if you compare to our human body also, if you are finding that some problem is in your health, then you can go to the physician and take proper treatment and avoid the surgeries and some typical problems which can be takes place if ignored. So here in this one, the monitoring of solar PV panel, it is to improve the performance optimization, to improve the efficiency of the system, then early fault detection, safety assurance, preventive maintenance. So many things we can achieve. One more chart I have added in addition to this. You can see now same things are given here. So it also affects the financial and operational benefits. It is possible. These days the data-driven systems are there used. Mostly that we come to know what exactly going to get happen, and we can go for the preventive maintenance. No need to go for the scheduled maintenance also. Condition-based maintenance we can go for this. That is a major advantage. In addition to it, it also helps for the grid stability and integration. So many advantages, and if you can go through the various literature, you will get lot of things there. So state of the art. Recently we have also developed one paper considering that I shall show you at the end if possible. Various techniques are given for the detection of these conditions, and so many things reported, starting from power models, IV tracing, infrared thermography. Then nowadays drones are also used for the monitoring purpose. IoT and Wi-Fi string measurements, Kalman filters, all things are well reported. And most of these techniques require important amount of data, correct data for the purpose of analysis. And lot of sophisticated sensors are also required. The major condition of the industry is that they say that you have to use minimum sensors, number one, because sensors are costly. Then they say that no If it is not possible, don't use the current sensor. Again, in a discussion they say, because it was a discussion with the panel, some professors from IIT also were there, and we discuss the thing. क्या हो सकता है, कैसा कर सकते हैं, क्या हो सकता है कि नहीं हो सकता है, कुछ पता ही नहीं, बस पैसे ले भी काम करना चालू करो, हमको कोई मतलब नहीं, वो जो पैटर्न है, और नहीं तो terms and conditions बनाओ. So that way we started. Nothing I know about it. I just collected one MTech student, and Shivpal is here. Shivpal assists me a lot in this. Here is Shivpal. So he is very good in the hardware. So we have started that one, and with this much we go to the literature survey earlier, near about 30 to 40 papers we have just gone through it. और कुछ जम नहीं रहा था काम, मतलब ऐसा लग रहा था कि फालतू में पैसे लेके बैठे हैं और पैसे खर्चे भी नहीं हो रहे थे. दो थिंग्स आर नॉट सो गुड. So research gaps are like this, and problem statement is very very clear that with minimum sensors you have to use it, because they have calculated the cost of the sensor. It was very much costlier one. So what to do again? Now these things are there. Most of the things are now, I think, that well documented in the literature also, different way, because AI and ML techniques are now available. So people are trying to give somewhat good solution, but still these problems are there in the literature, whatever I have referred. What about this kit? This kit Spark we have developed now. So if you can see, these are the research contribution of this kit. It is possible to detect each individual panel. What is the problem in that panel? It is possible to detect each and every panel. So in this one we just make use of the minimum voltage sensor. Okay. Considering the string only. One string is there, so then we are sharing, on sharing basis the sensors are used. This portable kit, it is there available now at the top floor. I think we have connected it. Huh? If it is possible, we will show. Then it is very good. It can give the recording also. Low power consumption, adaptivity is also there. And important thing here is that if there is an open circuit because of the shading and the anti-parallel diode, that is also monitored by this. So these are major advantages of this kit. And now come to the problem formulation. So many mathematics are always there now, so it is very difficult to get it. So again, I just try to minimize the thing, but okay, I will not go more in detail about it, just I will explain you what exactly we did. So here you can see now, this is a string. What is the meaning of string that you can see now? String 1, string 2, up to string m. And in one string, so n number of panels are connected like this. In general, this is the structure. And if you can see in a panel, the cells are connected in this way. See C11 to C1K, then C21 to C2K, and then CJ1 to CJK. And the anti-parallel diodes are connected like D1, D2 up to DG, like this. This is the structure of the solar panels. Various capacity solar panels and voltage solar panels are available. So we consider 300 volt solar panel for our work. And these things and how that angle delta, beta, and then cos theta, these are the general terms which are there, which are responsible for the generation of the solar power. So I shall not go more in detail. This is well given in the literature. Again, come to this is a very important point, that is irridance. Irridance we called it, and the solar generation depends upon only major two factors which we come to know. One is your irridance and the temperature. These two factors are very very important. Others are also there, but these are the major important factors. So we concentrate and we check that the location, various angles, the placement, how they affect, and it is provided here. In general, that voltage which is developed across the solar panel is depend upon, if you can see this equation here, one, the voltage which is generated by each and every solar panel, it depends upon the temperature and the irridance. This is the relation, well defined relation. And the So if you know the irritance, value of the irritance as well as the temperature, if you measure it, it is possible to find out the estimated voltage across each and every panel. So that we did. We used these two sensors, temperature sensors as well as irritance sensors near to the rooftop solar PV, and from that we have estimated these two values. So कितना बन सकता है भाई, कितना जनरेशन हो सकता है, सोलर कितना आउटपुट दे सकता है, how much it can produce, estimation just. So this is the first thing that we did, and here you can find out the voltage available across the string as well as across each and every panel. We can estimate it. Some additional thing that I shall also inform you. So first thing that we have just make a simple estimation by using the sensors. The sensors are calibrated. Then after that, we use the current voltage sensor only, and with the voltage sensor we determine whether that estimated voltage matching with the measured voltages across each panel or not. Estimated value of the voltage and the measured value of the voltage. We measure the value of the voltage across each and every panel. And estimated voltage is common in general. But if suppose there is a problem in specific panel, we will give a separate treatment. If suppose we know that that specific panel is say somewhat damaged, physical damage, we can come to know that okay, वो 90% देगा तो वो हिसाब से हम सेट करके रख दिया है उसको. We have set in that way. Okay. So estimated value we know the measured value, and now we determine the difference between these two, estimated value and the measured value. And once we find out what is the estimated value, what is the measured value, then from that we come to know what kind of problem is there. If the estimated value is more and your measured value is less, it means that there is some problem. What kind of problem, that we try to judge. So for different conditions it is possible, because different conditions, estimated voltage and irritance are different. So we are just matching. And if the difference is somewhat more, then it means that there is some abnormality. So these things are set now, estimated value, and accordingly if the estimated value is more than the measured value, then this is the abnormal condition. It means that there is a shading problem or debris problem, dust accumulation problem, or some other kind of problem, some physical damage problem, because your measured value is less, estimated value is more. And based on the difference, we also determine the threshold also. Means these two things are just matching with each other, only the threshold is defined. If it crosses, that difference crosses some defined range, it means that there is a problem. And if it is positive side, it means that this problem is because of the shading or some debris or accumulation or some physical damage or hotspot also. Then this is the shading condition, I said to you. Same thing about the open circuit condition of anti-parallel diode. So note it that the anti-parallel diode which is connected, if it breaks and there is a shading also, same ending operation. In that condition, it is observed that these things are coming there. That means the measured voltage is now goes to the negative side. This we have observed. So if it goes to negative side, means definitely there is a problem of shading as well as breakage in the anti-parallel diode. This we come to know. And with this much understanding, so we require very minimum sensors here, irritance sensor, temperature sensor, and these other sensors. So it is possible to detect that there is a open circuit condition of anti-parallel diode with shading. So if you can see here now, in this one, if I can show you more in detail, this very clearly mentioned here also. Why the voltage become negative? Because now this A2 get connected with the B1, and this is open now, and B2 is connected to this C1. That's why the voltage get reversed. So the negative voltage will come into existence only if there is a breakage in the anti-parallel diode and shading is also there. So this is reported by the development of this kit. This is a decision making and display circuit. If you can see this, it consists of your power circuit, that is the solar power circuit. Then here the gate driver circuit is used because power electronic circuit is used here because we have to use minimum sensors. So we are using the sensors on the sharing basis. Say for example, if you observe all the voltage of string 1, then we take some halt intentionally and or depends upon our 1 second halt, and then we move to the next string. All the string voltages we measure, each and every panel of each string on sharing basis, so that this power electronic circuitry will take care of it, and that programming is made there. So this is a switching circuitry, and this switching circuitry provides the information to the sensors, and sensors display the relevant voltages. These voltages can be stored, and then the processing unit compares the measured value of voltage as well as the estimated value of voltage. The data coming to the processing unit also from the irradiance sensor and the temperature sensor. See here. So you can see that the voltage sensor, so these are the sensor circuitry which consist of the irradiance sensor, temperature sensor, and only the voltage sensor. So only 3 sensors are used, no more than that. But okay, number of sensors are increased, voltage sensor will increase depending upon the number of panels connected in a string. So this processing unit determines it, and accordingly then we just use these LEDs. 3 conditions we display. Green LED will display if the things are normal, there is no any problem. Red LED will display if the shadow is there, shading is there, some hot spots are there, or debris or some dust accumulation is there. And then a blue LED is also used. It will display for the specific panel if the shading with the breakage in the anti-pallet diode circuitry is there. So this way the monitoring is made. So this time, this still date it is only the LED flashing circuitry is used. Now we shall try to convert here in the some other way, because these are old things, and now company also demanding that everything should be digitized, and some small amount of auxiliary supply is also required for the operation of the circuit. So this is the in general the methodology. The problem which we have faced, and still there are many challenges also, that I also want to point it out. This is the proposed algorithm, whatever we have discussed, it is properly designed here. Again, initially we initialize it by the location, attitude, and the geographical location, then the value of irradiance, temperature, season wise also that can be done, and the sensor gives the information. So whatever we discussed, that is there. And now this is our hardware setup. So we have just worked it on the 6 panels only with 2 strings. This is the circuit of this supply. The major problem what we are facing is that more number of cables are required, and now the company says that remove the cable. That is a major hurdle now. They are saying that because we are taking the cable for the measurement of voltage from each and every panel. That is a major hurdle. So if there is a problem in the cable, small wires are required, a bunch of wires are required. Now they are saying that no. So that solution we are also finding now. So this is the auxiliary supply circuitry, display circuitry. There is a kit, complete kit, spark kit, solutional panel analyzing and reporting kit, and some results are here. So I think that whatever we have observed in that condition with 960 watts per meter square irradiance and 30 degree temperature, these results are there. Normal condition. Intentionally we put a sheet on the solar panel so that the shading effect can be created. That results are also there. So green indicates that normal condition, if you can see the change in voltage at del P, set threshold value, it is less than that, so green condition. If you can see here now the partial shadowing condition also shown here. The red condition, there is increment in the voltage. The green condition. Then here you can see the anti-parallel diode condition. We should try to check if possible today. that demonstration is also there, na? I think video recording is there. We will show that video recording. Then if it is possible, we go partial shadow condition. So this video recording में हमने करके रखी है पूरे काम की. These some results are there for different panels. There are 6 panels totally, and some hardware result also collected by DSO. ठीक है, DSO भी बराबर आ रहे कि नहीं आ रहे वो भी देखा हमने. Some features को भी as I said to you that the major challenge here is that we don't want to use LED now. We want to transfer the data through IoT. That is the other thing, and another thing is the more number of voltage sensors are also required. So how to avoid them? Because for one string, depending upon the number of strings, number of panels they are required, and in addition to it, the cable problem is there. Small cables are required. So this is patented also in the year 2023, and we have transferred the technology based on that. They have give some suggestion, and they say that okay, now you again make some improvement in this work, and now this Gajanan will work on it. I think some references are given, and I urge you to see the video. वीडियो है ना भाई, इसमें दिखा दो ना. हाँ, यहाँ वीडियो दिखा देते हैं. हाँ, वीडियो इज देयर ना, so please play the video, and we will discuss also. If possible, we will show you the demo. It is a very small project, not so much big project.
Activities of that company.
The company, they are developing different models, and then they are working with some big companies like solar companies and EV companies also. They are just a sister concern, we can say. They are supporting them. They are doing like that. हो रहा है इसमें नहीं
Player है क्या वो?
प्लेयर है.
वीडियो प्लेयर.
10 मिनट का वीडियो है.
यूनिक ना, इट इज यूनिक.
किट बनाई है, उसमें बहुत सारे अभी अमेंडमेंट हमको करना है, वो हम करेंगे. अभी सर से भी सपोर्ट लेंगे. सोलर चल रहा है बहुत अभी. पीवी और ईवी का ही जमाना है सर अभी.
Meantime, if you have any doubts, sir,
हाँ, वीडियो है ना भाई, चलो करो, 2 मिनट लो, कोई प्रॉब्लम नहीं है. मेरे व्हाट्सएप में भी है वीडियो. हाँ, व्हाट्सएप से प्ले कर सकते हैं, फिर वो ऐसा करो. हाँ, हाँ,
नहीं तो ग्रुप
कैसे जी?
industry, attending industry and solving the problem.
No, it's a challenging, and you can see, so if students are working, industries are ready to provide the fund. There is no problem, but they are all the time pressurizing that do it. Huh?
To get the product.
They want the product only now, whatever it is. क्या क्या नहीं सर को बता. 2 मिनट टाइम लगेगा बोलते हैं.
हाँ ठीक है सर.
सर मैं देते हैं. हो मी चालू केलं की बसेल ना. गजानन ते त्याला सांगते का जरा पेनड्राईव्ह मध्ये घेऊन यायला. पेनड्राईव्ह मध्ये घेऊन ये म्हणा, शिवपाल पाशी आहे ना. व्हॉट्सअप नाही, त्याच्यापाशी पेनड्राईव्ह मध्ये पण आहे ना.
व्हाट्सएप डाउनलोड आ गया क्या?
वीडियो आ गया है, चलो फिर दिखा दो. आवाज भी है उसमें. त्याकडनं प्रिंटरमध्ये व्हिडिओ आणायचा होता तोपर्यंत. मला वाटतं तो रेडी ठेवला असतो. है पेन ड्राइव में बिल लगा दो, वीडियो आवाज के साथ है ना वो.
अरे मेल लॉगिन
ठीक है समझ जाएगी.
स्क्रीन असं प्रेजेंटेशन ऑफिस
हो रहा है. ठीक है. आवाज
फर्स्ट.
Okay, I will explain otherwise. So see the solar panels now. 6 panels are connected here in this way, and they are over the rooftop. And this is the kit.
Monitoring kit of PV panels. Here we can see that 6 panels are connected in series and parallel combination. 3 are connected in series, and there are 2 strings.
Start करें.
This is a condition monitoring kit of PV panels. Here we can see that 6 panels are connected in series and parallel combination. 3 are connected in series, and there are 2 strings. So 3 series connected panel connection and 2 parallel connection. The total 6 panels are connected, and none of the panel is being having any kind of shading or any kind of dust effect. So we can see that in our display unit, that is which is monitoring the condition of our PV panels. And green LED indicates that all the PV panels are operating in normal condition, and no abnormality or any kind of shading, partial shading is affected. Now we will shade one panel to find out whether we can get this changes in the display unit or not. Here we can see that P1, P2, P3, P4, P5, P6 has been indicating and mentioned, and all the LEDs are green. Green LEDs means healthy condition or normal condition. Now we will create an abnormality on panel number 3 by shading the PV panel. Now we have shaded the P3 panel. All other panels are not shaded. So this partial shading will create a voltage drop in that panel, and that voltage drop can be seen in this display unit as the panel P3 will turn red. Here you can see that the panel P3 has turned red. This red indicates abnormal condition or partial shading condition of panel. Now the same panel is having one of the anti-parallel diode. As it is a damaged panel, it's one of the anti-parallel diode is open circuited. So if we shade that part of the cells which are being open, which are part of that diode, open circuited diode, so what will happen is it will give a negative voltage due to that shading. So now we will shade that part of the panel which is having anti-parallel diode. Now we will able to see the effect on this LED display. Now it will turn from red to blue. As you can see that it has turned to red to blue. This blue LED indicates that the panel is having the anti-parallel diode is being open circuited. So in this way, this PV panel monitoring system operates, and it can find out the partial shading as well as partial shading or any kind of shading effect on our system, and the blue LED will indicate through red LED, and the blue LED indicates the anti-parallel diode condition of the PV panel. So, thank you.
Okay. So, any questions? Important thing is that hardware work. That is the major thing, important thing. Yes, all 300 volts, and we are providing near about 2 kilowatt generation. All. Now suggestions, if you give me, I will incorporate, and this is a PhD scholar, now he is working. So that's why we want to take this opportunity. Sensors, which sensors? No, voltage sensors are not embedded in the panel. We are connecting the wires, and from the wires we are bringing it to the kit, our power kit, and then the sensors are connected. Sensors are connected inside the kit, and then that sensors, then that algorithm is very difficult, no, because that access is the problem. First important thing, access is the problem. So that
They are designed to keep
that is the major problem again. So this is the hurdle. Again, that is a, here we did it, but nobody allow you to give access for the measurement of voltage. You start from that. And current sensors are more costlier, they are saying.
So what is the voltage difference? What is the threshold when you declare it's not working?
It is not working. Say for example, the threshold voltage near about 10 volt. We set a value initially, not so, because these panels are also old panels. They are not so new. We are not getting new panels. Some company gave it to us. They are there, and then the negative voltage minus 15 volt we set. That we are getting that value. Why?
No, I mean, you declare that this panel is not working. You have got an estimated voltage.
Yes, estimated voltage.
Measured voltage.
Yes, and the difference between them too. If it is more than 10 volt.
More than 10 volts.
Yes, here, but again, more precisely we have to work with it. Yes, yes. It is not only a thing because 1 volt or 2 volt, and there is also delay, no? Delay is also there because things are dynamic, they are changing continuously.
So can you not use a healthy panel as a reference?
Yes, healthy panels are there. Means some panels are healthy panels.
To estimate the voltage, not your theoretical estimation.
Huh.
So you use a healthy panel as a reference.
We can use it. 2 panels are healthy panels are also there
Yeah.
in available.
Yeah.
But if you can see the healthy panel, that data and this panel data, there is not so much difference.
Yes, correct.
That difference is very less. Near about 4 volt near about we are getting. Correct.
By that I mean that you don't have to estimate the voltage.
Okay.
the reference.
So you can directly, because estimation is a hazard.
Agree. But the thing is that the healthy panel will not remain all the time in healthy condition. Na. Shading will be there sometime later.
So
That is again the major
I
problem.
fully agree, but
Huh.
you can find a spot where you keep a healthy panel.
Huh.
Then you don't have to estimate.
Yes, that is correct. But again, the thing is that how we can say that the panel will be all the time healthy. That is again another issue raised by the company. He said that no, after some time it will become faulty. Then what we can do? So you give us a such solution. Correct, correct. Deterioration is also there in the healthy panel.
Instrumentation.
Deterioration of the panel. Hmm.
Because your estimate also depends on the formula.
Correct.
So how accurate is that formula? If other things change, the formula is not giving you the answer.
Yes, yes. No, but most of things are related to the angles and like that. So
But if it is
season wise, if you can see, there will be a change will definitely will be there.
so what is the problem if there is a shade, if the panel is sun is partially blocked, what is the problem? Is blocked.
Yes, but again in that condition, sun is blocked, so you will not get that much readings in that condition. Temperature will be also to get change.
You will not get
Temperature will also get change.
The radiance.
irritants will not get that much.
Correct.
So accordingly it will estimate.
Yes.
According to the environment condition, it will estimate.
Correct.
And then it will measure whether you are we getting that much amount of voltage. Or
Suppose there is a tree shade on the panel, right?
yes, that will be get monitored. So you have to trim the tree branch in that
Yeah,
condition.
tree branch, but then that is a normal operating condition. That's not a faulted condition.
Yes, that is also considered here. Na? Means suppose there is any kind of shading, if suppose monkey is there also, or some fault, some bird is also there, that is also get monitored. Yes, we come to know what here the problem, in which panel there is the problem. The specific problem, the specific panel we are trying to locate.
So how much does it vary with respect to temperature? The open circuit voltage?
Open circuit voltage that is given in the thesis, the variation with the radiance and the temperature, I'm getting that irritance as temperature, that graphs are there. At near about we are getting near about temperature variation what we have seen. We have checked it in the month of May, April and May. So we got somewhat less variation, means not so much difference we are getting. Because specific that month only, because the MTech project completed, and then after that, still that work is going on. Your question is very correct. For season wise, actually we want to work it out. Yeah, that is not yet completed. I do agree with you.
If it is 300 volts,
Huh.
so the range of variation is how much?
The range of variation, as we can see, means it goes to negative side also,
Well,
depending upon the situation. So maximum is 300 volt, maximum 300 volt open circuit voltage, and minimum minus 30 volt.
what I'm saying, in normal conditions,
Okay.
no fault, nothing, everything is already properly.
Okay.
If you want to know the variation of the open circuit voltage,
When in that condition, though no load is not connected.
nothing. So what
Nothing.
is the variation? Suppose the panel is rated for 300.
Okay.
So what is the variation in that voltage depending on the temperature?
No, that I just said to you, no, that means we have not considered that temperature and other irritants, because in the month of April and May we did not get that much variation. I do agree with you, no. So that is still to complete. Because only just soon as it's completed, the person come, we have given the demo and we finished that, because that MTech guy want to leave now, he want to join company. In hurry level. Now that is transferred to this Gajanan. Now he will do it. So your questions are very good. We will definitely think in that range and other things. And season wise also, because just we make a graph now for season wise, this is the graph. So we will just check last year तो ये graph था, अभी कैसा कितना voltage बन रहा है, क्या बन रहा है. So we will digitize it. That is not actually digitized.
But it is actually available in data sheet. Half volt per degree centigrade rise from STC. 25 degrees onwards, you just take the temperature.
Okay.
If it is, say, 45 degrees in Nagpur.
Hmm.
I'm talking about the surface temperature, not the ambient temperature.
Hmm.
The surface temperature will be at least 5 to 6 degrees more than the ambient temperature. If you have a sensor below the panel, we have a project. We have done this study with Commerce College, GS College of Congress Nagar, Shivaji Science.
Okay.
College, no, not Shivaji. Near to Shivaji, there is a
Garuda National.
Okay.
We had spent a lot of money just trying to compromise, just to see how we can keep the panel cool. First project was done at Sipna College of Engineering, Amrapali, 50 kilowatt. We had two identical systems. 25 kilowatt without cooling system, or 25 kilowatt with cooling system. There we had used the sprayers, the foggers below the panel. The problem there was they were giving us well water and it used to get clogged. The foggers used to stop. That project failed, we wasted money. Then we came to see, even going to Amrapali was expensive for us. So we convinced Garuda National College, because there we had identical system, 20 kilowatt, 20 kilowatt, parallelly working. So we could monitor the performance. So 20 kilowatt system, we had put the flower foam on the back sheet. So the question of the foggers getting clogged was solved. But when we put the temperature sensor, and we have data sheets are correct, half degree per degree centigrade rise in ambient temperature, voltage is correct. We had all the sensors put, we had even the water meter testing, of Engineering because I had approached BNIT that time. Medical was there. They were taking, ready to take interest, but somehow they were not very much keen. So Ramdev was very keen. So whatever data we had collected, we had a data logger also there. The entire data was given to Ramdev Baba. They did some research paper on that.
That is correct. It is your work is totally dependent on data. Here also, temperature. Actually, we are taking the temperature data. Number of sensors are required. In your case, number of temperature sensors are required below each panel. So that is not considered in this one. Which is only see with one panel it is possible.
Going back to the basic thing, did you say open circuit voltage?
Here we measure two types of voltages. Open circuit voltages we mainly concentrate because we are not connected in the converter.
Yes.
That's why we are not going to the load side voltage. That part is still pending.
So what voltage do you measure?
We measure the voltage across each panel when the converter is not connected.
Will there be an open circuit voltage? Why would there be a voltage?
Where?
Why should there be a voltage?
Without converter, that I am telling you. Before converter, we have measured the voltage.
क्यों होगा voltage? Something is wrong with my understanding.
वोल्टेज जनरेट हो रहा है, आपको हम दिखा सकते हैं अभी भी.
Diode, if you measure something against the diode, how would there be a voltage?
Where you want to say? I just come to the point.
Something wrong with my understanding.
No,
You are physically measuring the voltage है.
अरे नहीं, अभी उसको भी सर क्लियर करते हैं ना.
Against कैसे voltage?
आपका जो भी कहना है उसके बारे में भी हम बात करेंगे ना, ऐसा नहीं ना. ये देखिए सर, ये ऐसी कंडीशन है. दिस इज द कंडीशन.
तो उसमें कोई
अभी आपको मैं बता रहा हूँ, आई एम टेलिंग यू दैट कहाँ काम कर रहे हैं सर, पॉइंटर काम नहीं कर रहे हैं क्या? देखिए सर, यहाँ पे दिस पॉइंट ना, पॉइंटर कहाँ पे, मुझे पॉइंटर दिखाना है. हाँ, इस पे दिखा सकता हूँ क्या मैं? नहीं, अभी आ गया. हाँ सर, सो हियर we can measure the voltage across this point, this point, this one and this end point. This is the total voltage across the string, as well as the point, this P1 and this another point is across this one panel also. This point and this point also. We are measuring the voltage. We are getting the voltage.
What is it that will generate voltage? It's a diode, right? You cannot measure voltage across a diode. There is no voltage. Across a diode, there is no voltage.
Across the diode, no, we are not measuring across the panel. We are measuring the
The
voltage.
panel is a string of diodes, right?
Yes, correct. And is yes, you can see here, na. Here, that voltage gets generated. Here, the voltage gets generated across the cell.
You are
This
generating
total.
current, sir, not voltage.
Sir, we are measuring the voltage.
Current.
Correct. What you are correct. We are generating current.
Current.
Okay, you are saying.
Flow भी करेगा.
हाँ, बराबर है. हाँ, लेकिन हमको यहाँ पे हमने वोल्टेज मेजर किया हुआ है.
Something wrong with my understanding. I will have.
नहीं, हो सकता है मेरे में भी कुछ करेक्शन करना है, हम चेक कर लेंगे.
You take a diode, right?
Yes sir, this is the circuitry ना, totally I am showing you.
There is 0.6 voltage drop upon junction, but that you cannot measure.
No.
Because no current flowing. So how is it?
ये ओपन सर्किट हो गया.
कैसे मतलब without current flowing?
कौन सा अंडर which condition you are asking me, under normal condition or anti parallel diode breaking condition?
चाहे जो diode है ना.
हाँ.
है.
हाँ.
Anti parallel जो भी है. You are measuring voltage across a diode.
Yes, but that diode means you are saying that this voltage ना,
हाँ, जो भी voltage आप measure.
diode reverse condition में है ना सर, diode reverse bias है ना वो.
Does not matter. कैसे
हाँ.
measure करोगे आप reverse bias?
हम
सवाल ही नहीं है. Unless my understanding is grossly wrong,
हाँ.
which is good. If it is wrong, I'll correct it. But the point is that diode voltage you can never measure unless the current is flowing.
Correct. See, this voltage we are measuring now. We will see also this. These are the points where we are measuring the voltage, positive and negative points.
You must
हाँ,
be.
हाँ, हाँ, हाँ. Now come to the point. How it is measuring? Again, I will also think over it.
Load नहीं connected.
नहीं, लोड कनेक्टेड नहीं है. ये डायोड में से कोई करंट. नहीं
voltage is there, why current है?
हाँ, तो I am talking about power. They should monitor the power availability.
अरे वो यार आपकी बात छोड़ो, ये जो कर रहा है उसको ध्यान दो। The point is,
correct.
कर रहे हो, so
हाँ.
it is a good way for me to clarify my understanding that why there should be voltage. As I think, there can't be a voltage across the diode unless you are pushing some current. Or maybe your whatever voltmeter is pushing some current, I don't know. The voltmeter is closing the circuit, right? Voltmeter circuit close कर रहा है. The resistance is so high. Sorry sir, sorry for मेरा confusion मैं आपको transfer करता हूँ.
नहीं, मैं उसको चेक करता हूँ ना अभी। आपका कहना बराबर है। अभी मैं भी इससे क्या है 1-1.5 साल मैं दूसरे प्रोजेक्ट पे काम कर रहा हूँ, लेकिन अभी आपने जो बोला मेरे दिमाग में था ये भी, इसका भी मैंने आंसर दिया है उस वक्त, लेकिन अभी मेरे दिमाग से वो निकल रहा है। मैं आता हूँ पॉइंट पे भी, इट इज विथ मी। उस वक्त भी ये क्वेश्चन आया था जो आपने पूछा है ना, अभी वो निकल रहा है दिमाग से, पर इसका मैं आपको आंसर जरूर दूंगा कि वोल्टेज क्यों है। और ये मैंने इनको ये भी बताया था कि क्या होता है इसमें 2 कंडीशन, देयर आर 2 कंडीशन, शेडिंग प्लस एंटी पैरेलल डायोड ब्रेकेज का कंडीशन होगा तभी वो डिटेक्ट कर पाएगा कि ये ब्रेकेज हुआ है करके। उसको आई इज विथ मी, आई विल एक्सप्लेन यू, नो इशू। और सर कुछ और कुछ? पर आपका क्वेश्चन सही है उसको भी मैं साथ में लेता हूँ। गजानन भी कितना करेगा मालूम, उसको तो डेमो दिखाना है अभी। और इसमें 3 ही एंटी पैरेलल डायोड है, ज्यादा नहीं है। एंटी पैरेलल डायोड का काम एक ही है कि वहाँ उस पर्टिकुलर एरिया में अगर शेडिंग आ गई तो भी वो करंट भेजता है। ये उसका एक काम है पर्टिकुलर एरिया में। अगर लेकिन वो भी ब्रेक हो गया, हाँ है ना।
But basically, diode का open circuit voltage is hard to understand how. चाहे जो diode हो,
हाँ
unless current is flowing, you apply a voltage of current. या अंदर कुछ ऐसा होगा which we don't know. और the voltage probe है, that must be from the circuit.
कौन सी वोल्टेज प्रोब?
You are measuring voltage.
नहीं ये वो तो यहाँ तो हमने यहाँ पे मेजर किया ना सर, बाहर पैनल के बाहर।
हाँ, that must inject some current में.
कहाँ से वोल्टेज?
Any voltage probe do that, they inject some current and measure the.
हाँ तो कोई such a provision for injection of current.
There are various ways they can.
We can find it out. तो प्रैक्टिकल देखने का क्या? हाँ? आपकी इच्छा होगी तो चलो फिर किट तो देख लेते। एनवायरनमेंट पता नहीं कितना सपोर्ट करता है, लेकिन आपको धन्यवाद देना चाहूँगा कि मुझे आपने सुना इतना सब नहीं क्या, और मुझे पता चला इतना है करके। पर एक काम को भी आगे लेके जाएंगे, और हो सकता है गजानन की अगर ये रही तो शायद आप एग्जामिनर करके भी आ सकेंगे।
सर एग्जामिनर थे।
ओके,
मेरा जो स्टूडेंट जयगुरु आपको मिला।
So we should thank Professor Makarand Balla sir for his time and giving the expert talk.
मेरा काम ही है भाई।
Thank you sir.
थैंक यू।
Please join for a demo.
So this ends today's lecture session. We have a small demonstration by Professor Makarand Balla.
E-mobility lab.
So kindly join the lab, and after that we can visit e-mobility lab.
E-mobility.
By
Scholars
from
here to guide
yeah. Okay. Thank you.
you. Canteen.
And tomorrow session will start 9:30. Please be there before 9:30, at least 5 minutes before. So we will be having today very tight schedule. Tomorrow.
चलो वो Okay, fine.
So kindly be on time because we will be having two external from outside,
Yes.
and also you have to practice the whatever the Professor Kota has planned.
You want to.
He also want to take one additional session for you
Only
tomorrow.
program.
Thank you.
Who are running successfully, they have discussed. We want that session.